So we're going through differentiation, and this is a little bit about me. I got a 99.45 ATAR in 2020. I went to Pymble, and these are all the different subjects that I tutor in. Another few couple things about me is that I'm doing a double degree in law and economics and politics and philosophy, mostly economics. I grew up in America and I'm very much a nerd. I own it. It's completely true. So what we're going to be covering today are the basic rules of differentiation, the log and exponential rules, the chain rule, product rule, quotient, and trig. So if you're in year 12, hopefully this is a bit of revision, and if you're in year 11, this should be stuff that you're covering at the moment. Okay, so let's just get straight into it. To the person in the chat who said that the chat is disabled, thank you for letting me know. Of course, if you have any questions throughout, please put them in the Q&A and I'll do my best to answer them as we go through. A lot of the way that this seminar is going to work is I'm going to be doing examples with you, and I want you to try and do them with me or ahead of me and then ask any questions if it didn't make sense. Okay, so let's get into the basic rule. So this is the basic rule. This shouldn't be new to many of you. It should be fairly straightforward. So what we're doing when we're differentiating with respect to x, which is important, knowing what we're differentiating with respect to, is that we are taking the power down and then subtracting 1 from the power. I don't think this needs an example because it is fairly straightforward. So for logs and exponentials, the thing that I want to really focus on here is the difference between base E and base A, because I found that in schools, they kind of forget to teach you that. So these are the general rules for a log with a base of E. So what you're going to do is whatever's inside your ln there, you're going to differentiate it normally with that basic rule that we just looked at. And that's going to become the numerator of your fraction. And then you're going to take the original and keep it on the bottom. So if I wanted to, for example, differentiate ln of just regular x, that was the formula we were doing. Sorry if that's a little bit hard to see. I've got lines for the more extensive questions. But the derivative of x would be, we've got a power of 1, so take the 1 down, subtract 1 from the power, that leaves us with 0. So anything to the power of 0 is 1, so it's just going to be 1. And then the bottom is going to be our original x. So that should be fairly straightforward, hopefully. Now with the base e of the e to the power of f of x, what we're going to do is, again, use our basic rule to get, now this time it's going to be a coefficient, and then absolutely nothing changes in here. So if we wanted to do, again, the most basic example, if we had e to the power of x, the derivative of x, which we just worked out here, is 1. And then we keep everything else the same. So really the derivative of e to the x is just e to the x, which is quite a unique property. And that's awesome for a whole bunch of different graphing things. But here is the thing that they don't teach you. This is base ln a. So imagine it was ln 3 or 4. It's just a constant. It's a number, any number besides from e. So when we do that, as you can see, the beginning of the rule is the exact same, but we have to add a coefficient to the rule. And that coefficient allows us to then use the same rule that we were using before. And people are like, oh, why do we have to do something extra? I'm going to show you that what we were actually doing is not something extra. It's something we were doing back on this page, but we just didn't have to write it because it cancels out. So I'll show you what I mean by this. So if we wanted to say why this rule works, let's say, again, we're just going to take f of x is equal to, let's do a log of maybe 4x. That's very straightforward. So the ln of 4x. Now the f dash of x there would be, if we take this base a rule, when we're using this coefficient, we would have to do 1 over ln of e, because that's our base, right? It's e. And then we're going to multiply that by 4 over 4x, because the 4 there is our derivative of 4x, and then our 4x is obviously just the 4x. So we're following this rule here. But what happens with this one, the ln e? If you're not sure what that equates to, you can put it into your calculator really quickly. The spoiler alert is that that's 1. So really, we're just multiplying it by 1 on 1 times 4 on 4x. And so when we're doing any differentiation with a base e, because this cancels out to just be 1 on 1, we don't have to write it. So sometimes schools don't teach us that. But what we're doing in theory is we're actually doing this every time. It's just not necessary to write because it cancels out. Whereas if we had something where f of x was equal to log base 10 of 4x, having 1 over ln 10, if you're not sure what that is, I'm not sure what that is, you can put it in your calculator. It gives us a 2.3025 ... It's not going to cancel to be just 1. So that's why we have to leave that coefficient there. The other way that you can think about this, if it makes more sense to you, is you can use the change of base rule. So from here, your f of x could also be written, the exact same function could also be written as ln 4x over ln 10. That's just using the change of base rule. And then you see how I can then just differentiate this part as per usual, and we'd be left with the same thing, because this 10, ln 10 on the base, is what we're putting over here. Okay, I'm watching the Q&A and I'm not seeing any questions, so hopefully this is making sense. I'm just going to rub this out really quickly so I can go through the same proof with the exponentials. From my experience, I know that it wasn't really focused on, but it ended up being in exams a lot as something that they wanted to extend your or test further issues that were harder in the exams. And so I found a lot of people didn't know what to do, which is why I'm really focusing on this for the first couple of minutes. So let's use this rule here. So if we have a to the power of f of x instead of e, again, if we had, let's use 4x as well so that we're consistent. So if we had e to the power of 4x, the derivative rule would say that we have 4 times e to the 4x, because 4 is just our derivative of 4x, our power there. And then if we're using the ln a rule, we're going to have to put ln e there. But as we just proved with the last example, ln e is just 1. So really, we're just multiplying that by 1, and we didn't have to write it because the 1 is going to just disappear. It's just 1. Now, if we did the same question, but with a different base, so let's say we had a base of 2, so 2 to the power of 4x, and then we did f dash of x for that, we're going to have ln 2 times 4 times 2 to the 4x. And if you put ln 2 in your calculator, I just did it then, I got 0.6931 ... It's not going to cancel out to be 1, which is why we have to write it. Okay, so that is everything that I wanted to say about logs and exponentials. We've got our basic rules here with what we need to know, and then we've got the ln a. So for any base that isn't e, what you're gonna have to do. Okay, the chain rule. So this to me looks like a mess, and I don't think I really understood what was going on in it. I just applied it from my memory most of the time, especially when I was in year 11. Now that I am in uni, this makes more sense. I'm used to seeing this notation, but it takes a lot of time to get used to. And so don't worry if you see that and you're like, I have no idea what's going on. But basically, the chain rule, the gist of what we need to be doing, what you can see here is even though this is f of x, we're doing that same take the power down and subtract 1 like we did with a normal x. The only extra piece that we have to remember to do is that we have to find the derivative of the inside of these brackets as well. And then we multiply it out to the side. So the chain rule is super important so that we don't have to try and do this with the product rule or something like that, which we're going to get to. And it's quite nice and straightforward. So let's go through this example. So f dash of x for this question, we're going to identify that this 3 here is my n. So I want to bring that n down. I'm going to have 3. And then I'm going to multiply that by ln x but I'm subtracting 1 from the power. So instead of 3, I'm going to have 2. Now, the last step, which is really important, make sure you don't forget it, is that we have to do the derivative of ln x. So again, just revising those rules that we did a little bit like 2 minutes ago. We've got our f dash x over our f of x for here. So we're going to have 1, the derivative of x over x. So my final answer would just be 3 on x, because I'm moving this x to the front, multiplied by ln x squared. So that's the chain rule. And this seminar, it says it's a speedy seminar. We're going to go through a lot of content quite quickly. Hopefully that example made it make a little bit more sense. If you don't understand the notation, that's okay. Just remember, you're doing the same thing you'd be doing with an x, but also doing the derivative of whatever was inside that brackets. Okay, product rule. So the product rule is something that we use when we have 2 different sections that have x's in them. That's really important. If I just had a constant out the front, we wouldn't need to use the product rule. But if we have x multiplied by x in a different spot, that's when we're going to be using our product rule. So what you've seen here is I'm using u's and v's. If that notation is new to you, don't worry. All I'm doing there is I'm saying that my first term here is going to be my u, and my second term here is going to be my v. So it's a little bit more straightforward, and I don't have to try and do everything at once. I can break it down. So what I would then do next is I always use my little square. I think that that's super helpful. So I do my u, and I make that 14x squared. And then I do my u dash, which is good practice of our basic rule there. So we're going to take the 2 down the front. 2 times 14 gives you 28x, and then 2 minus 1. So just to the power of 1 there. Now, the reason why it's a square is because I have to go and do my v's now as well. So e to the x plus 1. Now, if I did the derivative of e to the x, I'm bringing down the derivative of x. So 1 times e to the x is just e to the x. And then because there are no x's included in this plus 1, that just disappears. Okay, now if we look at the rule here, we've got u times v dash and v here times u dash. So really, in theory, all we're doing is we're doing a cross multiplication almost like that. But it's important that you write out your rule each time because it will help you make sure that you don't make any mistakes. So we're going to do f dash of x equals 14x squared multiplied by e to the x plus 28x times e to the x plus 1. Now you could simplify that further. You could multiply, expand these brackets, find that common factor of e to the x with the x and the 14 and take that all out the front. So I'll just show you what that would look like, but it's not the most important thing that needs to be done in this question. So all of that is common. What I've done, I'll just change the color so that, oh, now I'm going to highlighter. I'll just change the color to blue. So I've turned this into 28x times e to the x plus 28x. So if we were then to factorize it again, oh, that's still in blue. If we were to then factorize it, we would take all of that out the front, and then in this term, we have just an x left over because it's x squared. And in this term, we have 2 left over because it's 28. So 14 times 2. And then we would have to add the 28x on the end. So see, I don't think that this is particularly simpler than this because there's one term that can't be factorized in both equations. But that is your product rule. The important things to remember, which I will write, I think this is probably the best color. So you want to remember to have only use it when x is in both terms. And you want to remember that you're to write the formula out each time. Because if you don't, then you could fall into the trap of accidentally timesing your u's times your u's or your v's times your v's. And it's just good habit to get into. And then if you do make any mistake, at least the marker can see that you've applied the correct formula, which is what you want. Okay, quotient rule. We're almost there. We've got another 10 minutes and we've got 2 topics left to cover, so I think we can do it. So the quotient rule here, what I want to first draw your attention to is obviously we're using it with fractions, or with division rather than multiplication. But the other thing is this negative here. So because we have a negative there, what you want to remember is that the order is so important. Because if we look back at our product rule, if we look back at our product rule here, when you're adding these 2 things together, you could do this one first or this one first. It doesn't make a difference. Here, it's going to make a difference. So you really need to memorize this formula. It's not just that simple cross multiplication like the last one. Okay, but we do set it up the same. So we're going to write out our U's, our U dashes, and our V's and our V dashes. So normally I would want to give you some time to try and work out what each of these pieces are going to be. But because we are only doing half an hour today, I'm going to power ahead. I see that we have a question. Most of these rules learned in year 12 is in year 11 so far. We haven't learned this. Okay, I am from New South Wales. So my syllabus may be slightly different to yours. I was taught all of this in year 11, but in Melbourne or WA, they might do it differently. It's also good to just be ahead. Hopefully that answers your question. I'm not sure if it does, but don't worry if you haven't learned it. Okay, yeah, thanks. So yeah, the U rule, let's start with our U. So that's going to be the numerator. That's the other important thing in the product. They're multiplied. It doesn't matter which one's U and which one's V. Here it really matters that the one on top is your U and the one on the bottom is your V. Now the bottom, you're going to have ln x. So the derivative of u dash, or the derivative of u, sorry, it's going to be 28x. I tried to use similar numbers to the last question. And then for v dash here, we're going to have, again, revising that rule, 1 on x. Okay, great. So we now just need to plug it into our formula. Fairly straightforward, hopefully. So we're going to do v, which is ln x, times u dash, which is 28x, minus our u, which is 14x squared, times 1 over x. Okay, so that's our numerator. Then what we do is we take it there and we do on the bottom, we square our denominator. Okay, now again, we could simplify this a little bit further. I'm running out of space. The most important thing that I would do there is I would make this 14x. We can also cancel, we can't cancel our log because we don't have a log in this term. That's really important. So don't make that mistake. But we can definitely have 28x times ln x minus 14x all over the same denominator there, ln x all squared. Okay, great. So that's our quotient rule. Again, remember your order. So by order, I'm meaning both in the formula. So using the minus, and which is u, and which is v. Okay, so hopefully that has got everything there. Again, drop any questions in the chat if you have any, and if you don't, we'll power on to the last rule that we're doing for today, which is trig. So this, I know in New South Wales is in the year 12 syllabus, but I think it is just as easy to learn now. These rules are also on your formula sheet, so you don't have to worry too much about that. At least in New South Wales. Again, I can't speak for other states, but I wanted to give you a range of rules so that you can kind of see there's a pattern that follows with each of these. So a lot of the time we're going to have that derivative of whatever was inside of our function. So with that log or with e to the x, we were taking them down and moving it out. With our chain rule, we were using it and then multiplying, putting this in the end. So they are quite similar, and there's a reason for that. That goes into higher level maths that you don't actually have to know the reasons for why these rules work the way they do, which is great. But yeah, these are the rules here. I think my best tip for memorizing them is that sine, it's the first, I don't know, for me, sine comes before cos. You always learn sine first. It starts at 0, which means that it's positive because it's the happy one. I don't know if that helps. That's always just how it's clicked in my brain. The one that's the weirdest one is this with sec squared x. So if you remember, your sec is going to be 1 over cos, and then it's squared as well. So it's a little bit weird, but just remembering that there, and these ones just flip between them. Don't forget this negative though for cos, that is quite important. Okay, so the example for this one, I wanted to do another product rule question, but using our trig rules. So let's start by constructing our table. We're going to do this every single time we have two things multiplied together or divided by each other. So our u is our cos x, our v is our sine cubed x. Now what you might notice here is you're like, oh, what do I do with that? Well, that's actually going to be a chain rule, because you can also write sine x as sine cubed x as with the cube on the outside. So I'm really trying to consolidate all the rules here. So we have trig, we have product, we have chain, it's all happening. So the derivative of cos, this is our -1. The derivative of x is just 1. So -1 times cos of x, or just negative, oh, sorry, not cos, negative sine, because we switch. We have negative sine x there. Now our v dash here, we're using our chain rule. So we're going to bring the 3 to the front. We've got 3. The sign stays the same, but we subtract 1 from the power. And then we have to multiply by our sine. We have to multiply by the derivative of our sine x, which is the positive one, and it's going to be cos x, like that. Okay, now a quick recap. If we remember what our product rule is, it's uv dash plus v u dash. So we're doing this little cross method here again. And so my u was cos x, my v dash was 3 times sine x squared times cos x. And I'm gonna have to do another line, plus my original v, which was sine x cubed, times my u dash, which is gonna be negative sine x. So let's just simplify this really quickly first. So we're gonna have 3 sine squared x times cos squared x, which you can see here, minus, because we've got this negative here, and then we've got sine x and sine x, so that's going to be sine to the power of 4x. And again, you could simplify it just a little bit more by taking the sine squared out, because it's a common factor, and then we would have 3 cos squared x minus sine squared x, like that. Okay, I was worried we weren't going to get through all of that, so I did go super fast. We have 3 minutes to spare, which I'm super impressed with, but I don't have any other questions. So if anyone had something specific that they wanted to ask, whether it was about any of the rules we've covered today or about differentiation in general, if it was study tips, anything like that, I'm happy to stick around for the next 3 minutes. And this will also be posted on our YouTube. So if there's anything that I went through too fast and you wanted to go through it again later, then it should be posted in the next couple of days. But does anyone have any questions? Okay, well, I'm happy to let you all go. Thank you so much for coming today. I really appreciated it. It's always nice to have people that you're speaking to, not just talking to a void. And if you're coming to the integration session that I'm taking as well, that is on at 1 o'clock. No worries. I'm going to end the meeting here because I don't think anyone has any questions. Thanks, everyone.